This video is about finding connections in nature, or in other words, what are some mathematical relationships that we see in nature? So let's start with a couple of examples. Let's say that you wanted to find the connection between soil pH and plant height. So in physics, we break apart scientific experiments in terms of three different types of quantities that you're going to be measuring in an experiment. Sometimes these are called the independent variable and dependent variable, but I'm going to call them manipulated quantity, responding quantity, and the controlled quantity or quantities. So for the first example here, soil pH is going to be our manipulated quantity. It's the thing that we can change or manipulate in the experiment. And then the responding quantity, the thing that we can measure as a response to our manipulation, as a response to the changing pH, is the plant height. So that's going to be our responding quantity. And then the controlled quantities are going to be the things that we want to make sure we control. We keep them the same each time we manipulate the pH, because if we don't keep these things the same, it might actually affect the responding quantity as well. So the amount of sunlight that the plant gets could also affect the plant height. So we need to make sure that that stays the same for every plant that we're testing so that it doesn't, mess with our results. The amount of water the plant gets as well might also affect its height. And even, of course, the plant species will affect its height. And so we don't want to be testing a sunflower versus an oak tree. We want to keep the species of plant the same so that we don't mess with that plant height in any other way except for the soil pH. So another example, what's the relationship between an airplane's speed and the amount of air resistance that it encounters? So in this case, the thing that we can manipulate is the airplane speed. The responding quantity will be the air resistance. And some controlled quantities that are important here that might affect the air resistance as well would be the shape of the plane. We want to keep that the same for every test. We want to keep the density of the air the same, and we also want to make sure the wind conditions are the same for each trial so that it doesn't affect our air resistance. So these are two different experiments that we could do and try to find relationships in nature. We always have a manipulated quantity, something that we're changing or manipulating, and then we also have a responding quantity that might go up or down as a result of our change. So let's talk about the first kind of discovery we might make when testing out different quantities in nature, and that is to discover that they actually are not related. We call this an independent relationship. They're independent of one another. So when you manipulate one quantity and it has no effect on the other one, then these two quantities are independent of each other. So an example of this would be the pairs of lucky underwear worn and the number of Cincinnati Bengals wins. So whether or not you like it, the amount of lucky underwear you wear does not affect the number of Cincinnati Bengals wins, or at least it shouldn't. And so this graph would look like this, where even if I wore 10 pairs of lucky underwear, it doesn't actually affect the number of wins. I could increase my number of underwear worn, and it doesn't change at all the number of wins over here on the responding quantity side. Note that we always put the manipulated quantity, the x, on the horizontal axis, and then the responding quantity is always the y value, and it goes on the vertical axis. So to write a physics equation that describes this relationship between x and y, you'll notice that x isn't even in it because it's not connected to y at all. Y is just equal to some random value k. The number of Cincinnati Bengals wins is just some random constant value here, and it has nothing to do with the number of underwear worn. So that x doesn't even show up in this relationship. So that's one kind of relationship. It's really not a relationship, one discovery that we can make. But the first major relationship I want to talk about today that we see often in nature is named directly proportional, or simply just direct. Okay, and so this one is whenever you change one quantity, the other responds by changing by the same factor or proportion. So notice proportion, directly proportional. You increase one quantity, the other one increases by the same factor. So you double one of them, you get double the other. So an example of this relationship in nature is the surface area of a magnet and the strength of that magnet. So if you have a small magnet, it might pull things pretty easily. But if you double the surface area of the magnet, you make it twice as big, twice as much magnetic surface, it's going to have twice the strength, twice the amount of pull, right? And so this experiment only works as long as you keep the same type of magnet in the experiment. So you don't want to have like a neodymium magnet versus just a regular old fridge magnet. You want to keep the magnetic material controlled in this experiment. But if you do keep that controlled, then you should find that if you double the surface area, you get double the strength. This graph looks like a straight line, like a linear graph here. And linear is another name for this kind of relationship. So you double the x value and you get double the y value. Now this is important because let's say you start with an x value of 3, right? I'm not using any units right now, but just for the sake of argument. Notice on this graph, an x value of 3 gives you a y value of 2. So what would happen then if we doubled the amount of surface area to, let's say, 6? So maybe we're dealing in square centimeters. So we've doubled the surface area to 6. Notice on the line, what did that do to the amount of magnetic force and the amount of the strength of the magnet? So if we make a dotted line over here, we notice that, okay, we've gone from a strength of 2 up to a strength of 4. So in both of these examples here, we have doubled. So we doubled the we doubled the surface area of the magnet from 3 to 6. And the response is we also get double the force. So this is why we call it directly proportional, because they change by the same proportion. You double the x value, you get double the y value. And this would work for a triple as well, or even cutting it in half. So if you go half as much, you get half as much. So they always have the same proportion. So the mathematical relationship here, the way we write this as an equation, is we say that y equals kx. This might look familiar, like y equals mx plus b. It has the same exact form. Instead of m in physics, we use a k to represent some kind of constant value that connects the two. It converts the units between x and y. But basically what this equation says is if you double the x amount, you get double the y amount. And so this is called directly proportional. So this is the first of 4 relationships that we'll talk about in these series of videos here. I've narrowed it down to 4 common mathematical relationships in physics for you. And so I want to keep track of that using this board here. And you will need to tune into the next video to see the rest of these relationships. I'm not including independent on here because it's not really a relationship. But for the directly proportional relationship, we said as x increases, y increases by the same factor. There's the equation, there's the graph. And so that's what this first of 4 common physics relationships will look like. We're going to look at the next 3 in the next video. So that's all I've got for you in this video. And remember, how you do anything is how you do everything.